Good afternoon, everybody. As Simon talked, we want to talk about the implementation of bioprocesses, the engineering role. Everybody knows what is bioprocess, so we have a short definition of that in the two next slides. So what is a bioprocess? It's a process with a pathway to transform raw materials into valuable products along a series of steps. They're different steps, as you may know. Bioprocess involves different things when we talk about biotechnology, biomass, organic waste, all of those things, agricultural rejects, all of those. And these new products, these new materials, or new energy involving, we can obtain these products and these materials by biofermentation, by biocatalysis, by biofuels, with some extraction or purification of biomaterials too, with some biofiltration and also with some biomass treatment. So what can we get from that? So we can get some drugs up to some energy. So drugs like vaccines, enzymes, proteins, pharmaceutical ingredients, some natural healthcare products, some food ingredients, some food additive, some chemical products as biopolymer, as succinic acid, like some speaker talk about today, and we can get some energy, so as biofuel and biogas too. So next step, if we want to achieve a project, if we want to implement this process, this bioprocess we are working on in the labs, what are the achievement steps? So we simplify it by 3 steps: the R&D one, the pilot test, and the scale-up test, and the bioprocess implementation itself. So the R&D is done in the lab. The pilot test is done in the research center or facilities that you can have at your home or with some partnership, something like that. And the bioprocess implementation is regarding the production plant you want to implement. And for this one, you need a lot of money, you know. So between each of these steps, we need to do some back and forth between these. And this is required because we need some new observation. We got some new observation at the pilot test. And also we want to confirm the design criteria during the implementation of the process. So maybe that it should be possible that at this time we need to go back to the R&D steps to get new criteria or new information to make sure that the bioprocess implementation will be done adequately without a minimum of risk for you guys. So what is the role of the professional in these implementation of the process? You know, there's some specific scientific, some chemists, name them, and there's also some engineers, as myself. So let's talk about this scientific team of the company. These people master the scientific content of the process because it's your home. These people can perform and also supervise the lab development, the R&D. They also perform and supervise, they can do that, the pilot test of the process. And they can supply the process scale-up data to the engineering team. And finally, they can participate. We want to improve, or we want to have them participate with the engineering team to the process implementation and the process startup, because they know some things. They have a lot of knowledge about the process. And now, what is the role of the engineer in these implementation? So the engineer performs and masters the process implementation compared to the scientific team. The engineer determines the requirements for the pilot test and the R&D for the implementation. They can assist and conduct the pilot test in collaboration with the scientific team of the company. And they can ask for new tests. Yes, they can ask for that at the R&D and the pilot steps to get specific data or information to get the better implementation without a limitation of risk. So this is generally for the engineer, but you know, there's a lot of specialties in the engineer. There are some process engineers, and also there is some mechanical, electrical, and civil engineers. So let's start to go more deeply in that. So what can do the process engineer? Normally it's chemical engineer, because we talk about bioprocess. We work with some chemistry. So normally we need some chemical engineers for that. So they are involved right from the start, beginning to right from the start between the engineering and the company. They are involved directly into the process because they know the chemistry, they know how to process with that. Then, you know, they are involved directly into the process. Yes, I did that. It's normally the direct link between the partners for the process, and this engineer know and develop also the operation units of the process. So you have to start from the raw material up to the final product. Now for the other specialties of the engineer. So they are involved for the specification. And they are working on the design of the plant, so the building, the electrical, and the mechanical equipment. As for the building itself, they are involved in the construction supervision and also for the commissioning and the startup of the plant. So when engineer is involved during this step, so as you can see in this figure, the engineer are involved during all the process, but depending on the step, they are involved. They are more involved at the end, at the implementation, compared to the scientific team here in red. But you know, we need a close collaboration between the two teams, between the two professional teams. So because we need to improve, or we need confidence between the two teams, and also we need assurance between the two teams, because we need to develop these. And if you want to minimize your risk, you need to mention all the things, all your knowledge to the engineering, to the engineers. Now, what is the engineer contribution? So this is the main steps for that. So they are involved, or for the process definition, they are involved also for the determination of the regulatory requirements, for the preparation of the PNID, so the process and instrumentation diagrams, for the equipment design and the specification of those, for the process control philosophy and the requirement in control for the process, and also finally for the process implementation itself. So let's go more deeply in each one of these steps. This is the following one. So about the process definition, what can the engineer have to do? He has to do determination of the scale-up and the design criteria with you, with the people of the scientific team of our client. So the engineer can ask for complementary information. He can participate to test preparation and execution of those. He has to work to determine the dimensional and adimensional variable. What is that? So when we talk about adimensional variable, let's say for these three examples, the LD ratio for the sizing of reactor, so length and diameter. The LG ratio for the liquid-gas contactor, liquid and gas flow, and the ratio C0 for the chemical reactors. So it's about the concentration. Now for the determination of the regulatory requirements. So it depends on the material produced. So if you want to produce a biofuel, it's not the same thing that if you want to produce a drug. So it depends on the market. Is it a biopharmaceutical product? If yes, so you have to implement GMP, you have to comply to FDA or to Health Canada, depending on your market. Is it a food additive? Also, if it's a food additive, maybe you will have to comply to HECCP. You will have also to comply to FDA or to Health Canada too. But you know, if you have some biofuels, maybe you will find some specific requirement regarding the flammable liquids. And if you want to perform some biofermentation, you will find some bacteria, so you will have some requirements, some regulatory requirement about that. And also the last thing, what is the safety issue? So NASAP should be a good thing for you and for all the team to minimize the risk again and to develop the better building and the better process for you. So the next step is the preparation of the PNID, so the process and instrumentation diagram. So this PNID is prepared closely between the scientific team and the engineer. The engineer don't know your process, and you know your process. The scientific team knows his process. So it's the reason why it's in close collaboration between those. So they have to prepare the mass and the energy balances. They have to determine the operation units to get the final product. They have to determine the requirement in equipments. So what kind of equipments we need, what kind of reactor we need, what kind of separation unit we need. Do we need a filtration unit? Do we need a certain quality of pump, something, all of those things. They have to determine the requirement in process control. Do we need to have manual control? Do we need to have a full automated control? All of those things. We have also to determine the way to manage the safety issue. So if we need to, if we thought that the HAZOP was required, maybe it's a good thing to do, but it depends on the product again. And finally, all other specific items related to the process itself. Next step. So we are now at the equipment design and the specification of those. So the process and the mechanical engineer. So it's the first time you see the mechanical engineer here. Have to calculate the size of the equipment. So they will use the adimensional variables we talked about a few minutes ago. They will size the piping, they will size the pump, they will determine the specification for the material. So will it be steel, stainless steel, HDPE, all of those. Material finish. So what is the roughness of the material you want to have or you want to work with? Is it crucial? Is it critical? Now, the mechanical and the structural strength of the equipment. What is the pumping capacity, as I mentioned also? Now, the process control philosophy and the requirements for that. So now the process and the control engineers will work together closely to answer these questions. So does the process need data logging system? You know, if you want to produce a drug, something like that, you will need to log your data. Does the process need automation, and at which level it will need that? Is a PLC required? Do we need some redundancy about the PLC? Is the process need to be validated? Again, for drug, it will be, right? It will be required for that. But if you want to produce biofuel, again, is it required? Maybe not. What kind of process instruments are required for this specific process? All of those. So now, the last about the process implementation. So we need to prepare the determination of the requirement for the building. How to comply with the regulation about the GMP, about HACCP, about Health Canada, FDA, all of those. How to avoid contamination. If you work with bacteria, if you do some biofermentation, you have to answer this question. How to make sure everything will be or is washable. Again, biofermentation need to have some equipment and also some part of the building washable to avoid any contamination and any problem in the production. Do we need some physical separation between all the sectors and also with the HVAC of the building? It's very important because if we don't have any separation with the HVAC, it will be possible to get some dirty air to the clean section. And it will be possible to have contamination of the site where you want to produce your product. So here we can find an example of a plant where we produce some proteins for the drug industry. So let's go back. Let's go to this slide in a few seconds. Here is the raw material arriving. We have here the fermenters, and the purification center. If you want to go from one room to another one, you will need some SAS. So we have SAS here. And we control the pressure, the air pressure between the two sides, the two rooms, to avoid any contamination again. We have a control room here also, so we have to control the personal, to control how the person can pass through the door from one room to another one. We need to control the access of those rooms again. So it's a short demonstration of that. So regarding the process and implementation again, we have to prepare the drawings, the specification, and the request for proposal for the construction of the building and the construction of the process itself, and also for the equipment purchase. So mechanical, electrical, civil, with support of process, will work on that. The engineer will also support the scientific team and also the company who want to implement this process to the request for proposal for the process and maybe something for the building itself. They will work also for the construction work supervision, and as mentioned earlier, they will work for the commissioning and the startup assistance during these steps. So now, what is the bioprocess control importance? Is it important? Yeah, it's important. So let's talk about the automation and control. We'll talk in a few slides about another kind of control. So what are the requirements in automation? How should it affect the product quality? Is the automation critical for the quality and the yield of the process? Does the process need data logging? So all these questions and more questions have to be answered by all the team, by the scientific team, by the company, and also by the engineering team to make sure that we will comply with the regulation, we will answer all the requirements of the process. So maybe we will have to demonstrate the compliance to regulatory requirement. So in this case, how to control the process? Which data should be logged? And how long shall the data have to be stored? So if you, and should the process validated? So if you need to validate your process, you will have to log data to make sure that the product will be with the high quality you mentioned. And you have to demonstrate a shelf life of your product. So you will have to demonstrate that you can get this product every time with the same quality, with the same yield, all of those. So maybe it should be interesting for that, and important too. So now, what's validation? It's a rigorous method to demonstrate that the process and the bioprocess and all the operation of the process do what they are supposed to. So the validation is made in different steps. So the first one is the factory acceptance test. So it's at the very beginning of the process when we want to implement the process. So now, what's a FAT test or a factory acceptance test? It's a mechanical and automation test at the factory prior to shipping. So you want to buy something, you give a specification, you give a contract to some fabricant, and prior to the shipping to your factory and your plant, you want to make sure that the equipment you bought is correct as your specification. So you can go to the site, you can go there to prepare some tests with the supplier, and you can assist to this test to make sure that it's correct, that all these specifications for the automation and for the operation of the mechanical will be correct. Now, when this stuff is shipped to your plant, your future plant, maybe you can ask for the installation qualification. So the installation qualification is due to demonstrate that the installation at your site is done as prescribed. So we prepared some specification for the installation. So what is the requirement in water, in steam, in all of those, and how it should be connected to. So this is the installation qualification. Now, when it's installed, you want to start up. You want to start it. So maybe it's possible, it's required to have some operation qualification. So the operation qualification is there to demonstrate the equipment do what it's supposed to. So about the quality, about the rate, about the yield. So these OQ is done on the site. And now at this moment, OQ is done mainly by the company, the owner of the equipment, and the engineers can assist them to prepare the documentation, to assist to the qualification, and to prepare the test also. And finally, when the equipment and when the factory is running, we need to perform some performance qualification. So it's to demonstrate that for a long period of time, the equipment, the process, will perform as expected for a long period of time. So validation can be performed on some critical operation units, on the entire process, on the building services. So about the HVAC, the steam, the water. So the water can be purified, can be deionized as you need. About the control access and maybe some other things. So since it's a rigorous method, each step of validation have to be well documented, because this documentation is signed by the persons involved in the design, in the construction, and the installation, and the operation of the equipment. And now the documentation is also used for regulation approval, so for FDA, for Health Canada, and all of those. So now we talk about the automation control. Now you're producing a product. Let's say you're a bioproduct by biofermentation. You need some quality control. So since bioprocess is related to biomass, to bacteria, to enzymes, there's some risk of contamination. You know, they can have some risk of contamination, and it's always present. So what is the impact of contamination in this kind of process? Loss of yield, loss in quality, loss of money too. And the big question, how long would it take to restart? You know, so how to avoid contamination? So first, by physical method. The construction of equipment. So is the equipment is washable? What is the surface roughness? Should we have smooth angles? All of those. Is clean in place required? Is sterilization in place required? So depending on the stability or the sensibility of your process, your product, these questions have to be answered. Now about the building construction for the HVAC. We talked about a few minutes ago. So maybe we need some pressure control across rooms, the quality of air filtration. Do we need some a clean room of class 100 or not? All of those. What is about the quality of conditions? Temperature, humidity, is it very important or not? We need to take attention also to the wall, to the floor, to the ceiling. Are they washable? Are they what about the smooth angles also? And now, finally, about the procedures. Maybe we will have to implement some procedures. So implementation of standard operation procedures, so SOPs. How to proceed. What is SOPs? It's to know how to proceed to each process step. How to proceed to quality check at the lab and in process itself, all during the process. So how to log data about the process in the building, because maybe we will have to log data about the pressure control, about the temperature of the room, all of those. How to manage errors. How can we manage the recall of products? Because if we have a drug, we will have to manage with recall of drugs. If we have some out of specification results, how can we manage that? and about the implementation of GMP and HECCP requirements too. So, thank you.
Thank you very much, Mr. Chabot. I think you made your point. There's a lot of things to do. And
Yeah.
we need you to do it.
Pardon?
And we need you to do it.
Yeah.
That's good. Do you have some question for our guest, our speaker? There? Do you have any example of customers that you had?
You know, Mr. Laurent Bernier this morning talked about BioEmber. We worked with BioEmber at the POMEX at the France site a few years ago to work at the implementation of HECCP there and like an ASAP or something like that there on the site.
I know there's a lot of university and CCP.
Yeah.
Do you have any research partnership with them?
Why not? Why not? No, you know, we are interested in research and development. We made some research and development in our labs, in our facilities. We want to work on the improvement in the implementation of those processes. So it's very interesting.
Because you know, university and college, we are there to train people also.
Yeah.
And your customer needs people.
Yeah, they need people. Yeah.
So you can help us.
Yeah, we can so. Yes?
If for example, I have one of projects at the bench scale, and I don't want to go forward. I would like to give lessons to people to develop. What kind of items for validation are required to get license, let's say, period, in case
Okay.
what kind of requirement in terms of validation.
In terms.
You are a customer.
Yep.
You have to you come and ask for license, and obviously you have to run some stable data. What kind of items of validation?
You know, you have a big question. It's not so easy to answer. You know, when we talk about validation or some requirements regarding bench scale and you want to license something, the first thing you have to do, in my point of view, it's not about the validation itself, as mentioned in the last slides. It's about the information you can get or you can give to your future client to make him more comfortable with the risk associated with the scale-up of that. So you have to work with some people about the way to minimize the risk and the way to determine what are the more critical variables of the process you have to license. I know maybe it's not a very defined answer to your question, but if you want to have a more defined answer to it, maybe we have to discuss together more. Yeah.
Okay, so we finish on that. Thank you very much.